Okay, solving systems of equations. There's two different ways I'd like to show you quick. If you have a system of equation like, for instance, y plus 3x equals 10 and y plus 5x equals 20. That's two equations, and you're trying to solve it and see where those equations would cross. Of course, you could graph both equations and see where they cross. But there's another way to solve it without graphing, and that is to solve a system. If you set them up like this, they're both in standard form, then when the x's line up with each other and the y's line up with each other, if one of them happens to just work out nice like this one does, where if I use the opposite here of each one of these, now I can have the y and that negative y cancel each other out right here. Okay, what I'm really doing is adding these equations together. And when you do that, if I have y and negative y cancel, they're gone. And the 3x and the negative 5x makes negative 2x. And then the 10 and the negative 20, when added together, make negative 10. X must equal 5. And so I found 5 is one part of my answer. Remember, what I'm looking for is where do these two equations cross? And 5 comma something is where they cross. The other part is where, if they've lined them up like that, using elimination method, the other part is the y. So if x equals 5, how do I figure out what y is? Well, I go back to either one of my original equations. It really doesn't matter which one, but these two are my original equations here. And if I have x equal to 5 for sure, then I can go put an x equals 5 right here, for instance, into that equation where x can equal 5. And I'll have y plus 25 is equal to 20. And then I subtract 25 from both sides. Y must equal negative 5. So if x is 5 and y is negative 5, I'm going to put the negative 5 right there. That's the point where they would have crossed. Now somebody might say, well, what if you had put the 5 into the other equation? It's still going to work. If I stick in x equals 5 right here, and I put the 5 in for the x, then I can now say y plus 15 equals 10. And look at that. Y has to equal negative 5 again. All right? So, for sure, if x is 5, we'll have to have y be negative 5. All right? That's solving a system using elimination. Now, what if I wanted to solve that same system using what's called substitution? Well, I'm going to back up here and show you what I would have done if I wanted to do substitution. Substitution means I take this equation and I solve it down for y or solve it down for x, one or the other. It's obviously going to be easier to solve for y. I'm going to take 3x from both sides, and I'll have y is equal to negative 3x plus 10. Now, why did I do that? Because now I can take that y is equal to statement, and wherever I have y in the other equation, which is right here, I can, instead of having a y there, I can take out that y and put in what? Negative 3x plus 10. So the negative 3x plus 10 goes right here. Now, if I say negative 3x plus 10 plus 5x equals 20, that's an equation I can solve. And the negative 3x and the 5x makes 2x plus 10 equals 20. Subtract 10 from both sides. 2x equals 10. X must equal 5. Just like before, we figured out that x has to be 5. It's just a different way to solve it. All right, so now that x is 5, 5 comma what? Once again, if I know x is 5, I can get rid of all this extra stuff here and go back to either one of the original two equations. I'll get those cleaned up here. So there's my original two equations, because there was a y there. And now I stick in x is 5. Same thing as I did last time. So if I put a 5 in, I can pick either equation, just like last time. Put a 5 there, and I'd say y plus 25 equals 20 and solve that. Y must equal negative 5. And then it's 5, negative 5. Okay, that's all I got for you on solving systems.